Hmm. Today, I am discussing about the radiation pattern of dipole antenna. This is the setup of dipole antenna. Before explaining the setup, I want to give some idea about antenna. A proverb is well known to us that we can live without food for a few days, but we cannot live for a few days without mobile phone. A children of age 3 is also addicted with the mobile phone. In the mobile phone, antenna is the most important part of the mobile device. So I should explain a few idea about the antenna. What is antenna? We have studied electromagnetic theorem in previous semesters. The idea of electromagnetic theorem is applied in the mechanism of antenna. Antenna is a device which can emit or receive electromagnetic radiation. For example, it is an antenna, but it is dipole antenna. What is dipole antenna? What is antenna? What are the antenna parameters? I am explaining step to step. That is, if we apply the varying currents, the word important varying currents, not steady current. That is, if we apply the varying currents in the device antenna, then electric fields and magnetic fields are produced. The sum of electric fields and magnetic fields are known as electromagnetic radiation. That is, if we apply varying currents, the electromagnetic radiation will produce from antenna, and simultaneously the antenna will receive the electromagnetic radiation from air. It is a simple idea about the antenna. From the beginning of the antenna age, the antenna size was very large. In our houses, we see that dish antenna. That is, every family use Sunday HD. That is the dish antenna. That is, which aperture or size is large, but our mobile phone size is small. That is, which type of antenna is utilized in the mobile phone. In the modern communication age, we are enjoying 5G, that is fifth generation. We have across the 4G, 4G LTE. LTE means long-term evolution. That is, we have experience about 4G, 4G LTE. In 4G or 4G LTE, the download speed, data speed are not much. So the researchers, engineers have discovered 5G. In our country, in many states 5G is applied, but in the modern or foreign countries like America, UK, 5G is utilized in before 7 or 8 years ago. We have now tested about the 5G. In 5G, more facilities are enjoyable, like data speed is so much high, latency, no latency, that is interruption during download, that is known as latency. In 5G, latency is less, but for 4G, 4G LTE, latency are high. So after long struggle, we are enjoying 5G. In 5G mobile device, antenna is key factor. About antenna, the basic idea is given before a minute ago. Many types of antenna are consisting in the world, like compact antenna, microstrip antenna, whose size is small. Here, this is the dipole antenna. Its size is small or large, both may be considered. But compact antenna, which is in our TV, mobile phone, compact antenna size is small. That is the today I will discuss about the radiation pattern of dipole antenna. There are many key parameters of antenna like S11, VSWR. S11 means reflection coefficient. VSWR means voltage standing wave ratio. We will discuss here the radiation pattern. The radiation pattern can be explained through many simulation softwares like CST, HFSS. But here we will explain with the help of antenna trainer. This is the antenna trainer. It consists a few parts. This is the RF generator, that is radio frequency generator, directional coupler, modulation generator. This is the transmitting antenna. Transmitting antenna will transmit and receiving antenna will receive. This is the receiving antenna and this is a transmitting antenna. Transmitting antenna, you see that transmitting antenna is connected with the radio frequency generator. That is, radio frequency will supply through this antenna and antenna will emit radiation. This radiation is captured or received by the receiving antenna. This receiving antenna is connected with RF detector, that is radio frequency detector. RF detector, here you see that microampere, that is radio frequency current, is measured in microampere and transmitting antenna current is measured in microampere also. So we will start to take the data for radiation pattern. Before this, I want to show this is the goniometer scale. Clearly you see that there are degrees, 0 degree, 10 degree, 20 degree to 35 degree. That is 360 degree are divided many sections. This is the goniometer scale. First of all, we have to supply the current in transmitting antenna. Before taking reading, some points are to be remembered. The height of transmitting antenna and height of receiving antenna will be same, because the radiations can be detected at the same height and the readings will be well. So the height of the transmitting antenna and receiving antenna will be same, and radio frequency generator, this is the level. Before taking reading, we should increase or should level the radio frequency generator. I have labeled thus. This is the 750 megahertz. 750 megahertz generator. That is 750 megahertz frequency will be supplied by the transmitting antenna. And there is also level adjust microampere radio frequency detector. I am also leveling by increasing the level. This is dipole antenna. It is lambda by 4 dipole antenna. Lambda by 4. Dipole antenna means it has two poles. That is one pole. There is one pole. That is one pole. You should idea about the transmission line. That is the two lines transmission line. That is the energy will be supplied to the device through this line. This is a lambda by 4 dipole antenna. I have set up the half wave dipole antenna. Half wave. You see that lambda by 4 in my left hand and lambda by 2 in my right hand. The size of the lambda by 2 is larger than the lambda by 4. That is when we increase the frequency, the antenna size will be reduced. Lambda by 2, that lambda is the wavelength of the supplied energy. This is a metal rod, one metal rod and one metal rod, that two metal rod and transmitting line. Now we set the half wave dipole antenna thus. I have to adjust the height, same height, and also a key parameter should be remembered that transmitting line and transmitting line, there is a gap. The gap line is also in the straight line. Thus, we can detect the emitting antenna by the receiving antenna clearly. Now we will start to take the reading. First of all, I give the energy power in the radiation in the transmitting antenna. That is, energy is supplying in the transmitting antenna. We will label okay. This is the antenna trainer. I have told you that this is the transmitting antenna. Now I am leveling. That's the level, and there is the FS adjust. I am increasing the FS adjust. You see that there is a transmitting current 17.9 microampere. 5 on microampere. And at this situation, you see that detector current, RF detector current of the receiving current is thus 28.9 microampere. Actually, I have to increase smoothly, but I have increased sharply. So, smoothly, if I increase smoothly, then the adjust will be right. Actually, to draw the radiation pattern, we have to take the radiation frequency detector current in microampere. After obtaining a few values for the various degrees 0 to 0, 10, 20, 0 to 360 degree, then the microampere currents will be obtained, and microampere currents will be converted in the decibel. there is a radiation pattern degree is in the decibel. After all, the radiation pattern shape will be do not shape. If you see that here is a marker and the marker is 170 degrees. If I adjust, marker is on 0 degree, marker, you see the marker, this marker is 0 degree and the antenna is dash. That is, if we increase, you see that at the initial stage the microampere current is 36 degree, but we should care that microampere current from radio frequency detector will not exceed 30 degree at this initial state. If we increase thus the degree of radiation 20 degree or 20 degree, 37 degree, 30 degree, 25 degree, 40 degree, 28 degree, 60 degree.
0.6.
Actually, I am increasing sharply, so the radiation degrees are up and down, but it should be smoothly. After all radiation pattern from the radio frequency detector will be plotted in the graph, and the graph size will, and the radiation pattern shape will be do not shape. This is the radiation pattern of the dipole antenna and the mechanism of the dipole antenna. So I am now closing the class.